In this video, let us understand the working of bridge rectifier. The circuit diagram is shown in the figure. During positive half cycle, terminal A is positive and terminal B is negative, which makes diode D1 and D3 forward biased, D2 and D4 reverse biased. During positive half cycle, terminal A is positive and terminal B is negative, which makes diode D1 and D3 forward biased, D2 and D4 reverse biased, and hence diodes D1 and D3 will conduct, D2 and D4 do not conduct. This is the equivalent diagram during positive half cycle. So during positive half cycle, A is positive and B is negative, where D2 and D4 reverse bias, hence they act as a open switch, and D1 and D3 forward bias and they act as closed switch. There is a flow of current from terminal A via D1 through RL via D3 towards terminal B. The flow of current through RL develops the voltage across the load resistor RL, that is the output voltage. During negative half cycle, terminal B is positive and A is negative, which makes diodes D2 and D4 forward biased and D1 and D3 reverse biased. Therefore, diodes D2 and D4 will conduct and D1 and D3 do not conduct. This is the equivalent diagram during negative half cycle. During negative half cycle, there is a flow of current from terminal B via D2 through RL and via D4 towards A. So the direction of current during negative half cycle is same as the direction of current in positive half cycle. In both positive and negative half cycles, the direction of current through resistor RL is same, which produces a output voltage which is pulsating and unidirectional. The input and output waveforms are shown in the figure. During positive half cycle of the input signal, and this is the positive half cycle. During positive half cycle, the output voltage is produced across the load resistor due to conduction of diode D1 and D3. During negative half cycle, the output voltage is produced because of the conduction of diodes D2 and D4. Again the cycle repeats. During positive half cycle, the output voltage is due to conduction of D1 and D3, and during negative half cycle, the output voltage is due to the conduction of D2 and D4. In the output waveform, the DC voltage, average output voltage VDC, is represented and shown in the dotted line, which is equal to 0.636 Vm, where Vm is the peak value or maximum value of the input signal. The expression for output voltage is given by the equation VDC equal to 2 Vm by pi, which is equal to 0.636 Vm.